The night sky is something we all take for granted. It was there when we were born, it will be there when we die. Most people don't give it that much of a thought. But what if I told you that it tells us far more about the universe than you might think? And no, I'm not just talking about pointing telescopes at it. My name's Thomas Rintoul, this is the second ever episode of Short Science, and today I'm going to be talking about how the mere existence of a night sky tells us the universe has a beginning. The nature of the universe has fascinated humanity for millennia. We've tried to answer the question, does it have a beginning? Will it have an end? Has it always existed? Was it created by someone, something, spontaneously? There have been many attempts to explain it, whether from the philosophical, to the scientific, to the religious. Our knowledge of the universe has increased exponentially in recent years with new telescopes and new technologies. We can see further than ever before, and we've found something out. The universe looks roughly the same everywhere. It looks roughly the same in all directions, the distribution of stuff is pretty consistent. On small scales there are massive variations. For example, the space around Earth is clearly at a much lower density of matter than the Earth itself. But on the largest scales, when galaxies are considered small, the universe is fairly consistent, fairly the same, fairly homogeneous is the scientific term. What this means is that looking in any direction, whether that's from the northern sky, the southern sky, straight out of the equator, the universe looks pretty much the same, ignoring, again, smaller changes like we can see the sun over there but not over there. This is what we call the universe being isotropic. It looks the same in all directions. These two statements, that the universe is both homogeneous and isotropic, are things we can't conclusively prove. We can't say for certain that the universe is the same everywhere because we can't actually see the entire universe. I'll come back to that later. Despite the fact they can't be proven, we can prove a lot of other things if we assume them to be true. In fact, the rest of cosmology pretty much works, assuming that these two statements are true. These are called postulates. They're things we can't 100% prove, but they make everything else work. And these two postulates are part of the reason we know that the universe has a beginning. Working from these two postulates and saying that the universe looks roughly the same everywhere, then if the universe is infinitely big, it goes on forever in all directions, then eventually along every single line of sight, we will eventually hit something that emits light, be that a star or an accreting black hole or something. What this means is that if the universe is infinitely big and also infinitely old, so it has existed forever and there's been an infinite amount of time for things to happen in the universe, then this means that along every single line of sight, every single direction you look, there's been an infinite amount of time for light to travel to you. Then because along every single line of sight you hit something that emits light, that light will have reached you. If this was true, if the universe was infinitely old and infinitely big, then the night sky wouldn't be dark. It would be incredibly bright. This is something called Olber's paradox. Olber's paradox is this statement that an infinitely large, infinitely old, homogeneous universe would never have dark skies. You would always have bright lights in the sky. Olber's paradox is fundamental to the notion for an origin to the universe. The night sky that we see is just not consistent with an infinitely old and infinitely large universe. What it is consistent with is a universe that has a finite age. There's only been a set amount of time for light to travel to us. Essentially, Olber's paradox requires something like the Big Bang Theory. If there is a beginning to the universe, then we get a night sky, because it creates what's called the observable universe. The observable universe consists of all of space that has had time to transmit light to us and be received. This means that any light emitted in the last 13.8-ish billion years has reached us. Anything in that distance of 13.8 billion years worth of light travel is in the observable universe. Now, the reason I'm not saying 13.8 billion light years is because of expansion and not within the scope of this video. Any light that would take more than 13.8 billion years to reach us, well, we haven't received it yet. We don't we don't know anything about what lies beyond the bounds of the observable universe. Because there is this limit to how long light has to travel towards us, it creates the possibility that along certain lines of sight, there hasn't been any object to emit light towards us. This gets rid of this problem that the night sky shouldn't be dark, it should be bright. It gives us our dark night sky. It tells us that there was a start to the universe. It tells us the Big Bang Theory is the right direction to look. Now, we don't know everything about the universe yet, but Olber's paradox about the night sky at least tells us that we're right in saying it has a beginning. If you have any topics you'd like me to cover in a future Short Science, then please leave them in the comment section below. If you didn't see my last episode of Short Science about whether or not it's astrophysics or astronomy, then please do check that out in the top right hand corner. In the meantime though, I've been Thomas Rintoul, this has been Short Science, and I'll see you in my next video. See ya!